back.
Great job, everyone. I must say, your hard work and dedication really paid off. I didn't know if I'd be making this video. I thought I just might make it. There was part of me that was like, I'll make it just to be nice. But no, you earned it. You earned it 100%. There was no question. I'm making the video because you worked hard and you made it happen. So chapter 15 is one of the toughest chapters we have, or it's where things really pick up steam. And let's start taking a look at these problems. Although this problem is on your first set of questions, we will review it right here. Now, this bank knows that apparently 11% of people do not make their loan payments on time. This is from their past experience, as you see right here. 11% of people do not make their loan payments on time. This is what we would expect. If we give out 1,000 loans, well, we expect 11% not to be paid on time. If we give out 300 loans, we expect 11% not to be paid on time. 200 loans, we expect 11% not to be paid on time. So we will use this as what we expect. That means it'll be the mean of the distribution. Let's go over here and go to the David M. Lane applet, which many of you are familiar with right now. It's just going to display the normal curve. I'm going to make this very small for the time being so it doesn't distract. Let's go ahead and just put it to 0.1 as a placeholder. That's just a placeholder. With this in mind right here, we can see the mean. This is what we expect. We need to now find the standard deviation. So we expect 11%, but let's go ahead and find the standard deviation of this distribution. The standard of this deviation of this distribution can be found by doing P times Q over N square root. So let's do this on our calculator right here. Let's go to calculator. P is 0.11, Q is 0.89. They are complements of each other. They both add to 1. If you notice that right there. That's P times Q over N, which is 300. I can't type today. P times Q over N, and then we square root it all. Nice and easy on the computer calculator. P times Q over N square root. And a lot of times I'll just copy paste this in so we don't lose any decimals. So we can just bring it down here to just a few decimals. It wants it to 3 decimals. 3 decimals right here. One more. There we go. 3 decimals. So this is the mean of our sampling distribution, and this is the standard deviation of our sampling distribution. This is for the proportion of bank loans we do not expect to be paid on time. And it's kind of similar to what I had as a placeholder, but this is the actual standard deviation now. So what does this mean? It means when we go out and sample 300 bank loans, we expect to see 11% of those bank loans not paid on time. And, you know, within the bounds of reason, I don't know, 15% would be a lot, 14% still kind of a lot. 2 standard deviations would suggest 7.4 to 14.6% is the central 95% kind of normal range we would expect. So we generally denote an outlier as anything above 2 standard deviations or below -2 standard deviations. Outside the range of -2 and +2, these would be kind of extreme occurrences. This once again applies with our empirical rule with 95% of the data inside of -2 and +2 standard deviations. Let's go ahead and look at the problem right here. Now the conditions are random. We need to randomly select these. 10%, they need to be less than 10% of all bank loans. And also success failure, which means we need 10 expected successes and 10 expected failures. On the test, it must say that these bank loans were randomly selected. Although we can assume for this that they were, on the test it needs to say they were randomly selected. Next, we have the 10% condition. I would assume this bank gives out more than 3,000 loans. If you look at 3,000, 10% of that is 300. So if they give out more than 3,000 loans, we'll have sampled less than 10% by sampling 300. The reasons for the 10% condition deal with the mathematics we do, an error that occurs by sampling more than 10%. There's a longer reason for this, and that is the reason, but I can go into more detail. But if you just want to know for the test, sampling less than 10% is good. We do not want to sample more than 10%. That is the 10% condition. Next, we have the success failure condition, and this always pops up when I try to do my videos. It never pops up when I'm not doing them. Next, we have the success failure condition, which states 10 expected successes, 10 expected failures. To get the number of expected successes, we need to take n, which is 300, times p. That's the number of expected successes. To get the number of expected failures, we need to take n times p, or n times q, excuse me. And if you notice, 33 plus 267 equals up to 300. NP plus NQ equals 300. So with assumptions, we have met this, but on the test, it must say random. All the other ones we actually checked. On the test, I would probably say it did not say they were randomly selected. I have a problem with that. Next, we want to look at the possibility of over 12% not being paid on time. Not too hard to do this, and on the test, we might just give you the graphic. Let's go back to the graphic here. You could shade on here this. Now, if I'm shading right here at 12%, which is right about there, I'd say, that's a z-score of maybe, calculate it ourselves, but it's close to 0.6 or something. I'm actually thinking in my head, and heck, let's actually z-score it. Why not? So we're going to take observation of 12 minus mean of 0.11, and then divide by standard deviation, which I do not believe I have saved in here anymore, but it looks to be, let's bring it back up, standard deviation is right there. Observation minus mean over standard deviation, which is 0.01806, and I said it's about 0.6, and it's close to that, very close to. So that is the z-score of it. Now what does that mean? That is how many standard deviations we fell above the mean. So we fell kind of close to the mean. This isn't an odd thing that occurred if 12% happens. That could happen a lot of the time. When I get this area down here at the bottom, when I graph more than 12%, which I think the question wanted more than 12%, let's take a look at it. It wants more than, if you notice down there, let's click on it. This says the probability that the sample proportion p hat is more than 12%. Just read it. Probability sample proportion greater than 12%. Next, we look at it on here on the graph, and we notice above one standard deviation is 16%. Above the middle point is 50%. So with this in mind, that's all from the empirical rule, my percentage down here should be more than 16, less than 50, and it is 28.99. Now you always have to watch on these assignments because here it wants to 3 decimals. That's going to be 0.29. So let's go ahead and hit submit quiz. See if we got it correct. I know I have a bunch of uncompleted questions. Got it all correct. So let's go back. Here we are on question number 2. On question number 2, we're looking at a school referendum. And they want to look at the probability, let's see here, that the newspaper's sample will lead it to predict defeat. In this problem right here, the budget has the support of 55% of the voters. This is the truth right here. Does everyone notice this? This is the truth. 55% is the actual truth. What we're going to pretend here is that this does not occur, as in we would observe less than 50%. This problem confuses people because it never actually says less than 50%. It just says that it will predict defeat in their sample. The truth is 55%, and they're going to go out and sample 441 people. What is the probability that they find less than 50% supported? Which is possible. Imagine, there's some, election at UT, SGA election, and the people who win actually have 55% of the support. If we go out and sample 441 people, might we find that they have less than 50% support? I mean, that happens when you go out and sample. It's just sometimes you don't get the right people and you get something that's a little bit odd. So let's go ahead and solve this. We need the mean and the standard deviation of this distribution. So let's go over here. That's the assignment manager. I had to hop back in. Let's go ahead. The mean of this distribution is 0.55 because that's what we expect. We expect to see 55% support. Next, we need to do P times Q over N square root, and N is 441. P times Q over N and square root. This is the standard deviation of the sampling distribution for the proportion. Right there, we have it. the standard deviation for the sampling distribution of the sample proportion. Let's take a look at this right here. As you can see, 50% is down here about at -2, which means it's not likely to occur. The great thing is when we click below, and we could z-score that, z-score of about -2.1. You can find it if you'd like. To heck with it, not that hard to find it. We've already got the standard deviation here. Observation minus mean. See, this is negative now because we fell below. You know you've done it correctly if you get negative. Divided by standard deviation, and I said -2.1. I was very close. You can just view it graphically. Observation minus mean over standard deviation, which is p hat minus p over the standard deviation, which is p times q over n square root, which we've solved for down here. Okay. This is the actual answer right here. It's the probability that if this is the truth, we would see in our sample this. The answer is going to be less than 2.5, but greater than 0.15%. And that's in terms of percentage. As you see here, it's 1.7%. So it seems like we will not find this. It would be very odd if in our sample we saw predicting defeat. Just delete it down, and there we've got it entered in. We'll do 2 problems here, see if I can get them both correct. Okay. It is believed that 4% of children have a gene linked to juvenile diabetes. Researchers at a firm would like to test a new method of such and such. What they want is to have 22 children with the gene for their study. So what we have here is a supposed truth. It's supposedly true that 4% of children have this gene. So let's go ahead and put 4% as our truth right here. And this is just a placeholder right now. So the truth is supposedly 4%, which is the most likely thing for us to see when we go out and sample. What we want to see is we would like to see 22 out of 731, which is 3%. What this is saying right here is if we get 3%, which is 22 out of 731, we'll be happy. And that is the sample proportion we want to see. So what we need to do now, this is p hat, the p hat we want to see. What we need to do now is take p, you got it, find the standard deviation, times q over n square root. And this is the standard deviation for the distribution of sample proportions. I think I said it right that time. The standard deviation for the distribution of sample proportions. Woo! P times q over n square root. Okay, let's get it entered in here. Now, once again, I'm going to solve for the, the p hat. Let's take p hat here again. P hat was the number of successes over the total number of trials. I just want to get it to all the decimals. Never hurts to work these things out ever so carefully. And we want to see that we have enough children. So that would be right here. If you notice, 3% somewhere in here, a z-score of about, it's very close to -1.4 or so. You can solve that one exactly, -1, -1.4-ish. And it looks highly likely that we will have the children needed. Because using the empirical rule, above here is 97.5%, and above here is 84%. If I make any mistakes in these videos, please email me, but I've been doing this a lot on these, and I hope I don't make mistakes. Above this line to the right is 97.5%, and above here is 84%. As I'm saying, like above. So this is between 84 and 97.5, and we get this value right here. It looks pretty likely we're going to have the children needed. So the probability of having enough subjects is right there. Let's go ahead and check our answers. Good deal. Okay, time to restart the quiz. This question rips people apart because it makes you think about things a little bit differently. Apparently, studies show that 59% of people demand a smoke-free area. I mean, they have to have it. If they don't have that smoke-free area in restaurants, which really doesn't apply here in Tennessee anymore, they're going to be really angry. So what we want to say is, if we have 136 people come into our restaurant, what percent of people would we expect to want non-smoking? And the answer is, well, according to it, the demand, and let's bring back up the z-table here again, we'd expect, I believe it was 56%. That's the expected proportion. 59% rather. Because that's what studies show. If we have people come into our restaurant, we'd expect 59%. Now what do we need? You got it. We need the standard deviation of this distribution, which can be found by doing P times Q over N, square root of this whole quantity. Now, I want to make clear, we've been doing a lot of these right here, and you have to be able to identify these problems and know the differences between, and I have made a mistake in my copy-paste. You have to be able to identify the differences between these problems we're doing here and ones with means. We also haven't talked about the conditions in a while. The problems we are doing consist of questions where the answer is more of a yes-no option. Do you want smoking or non-smoking? Are these children nearsighted or not nearsighted? Will people vote yes or no on the bill? It's not a quantitative response. These have all been categorical response. So these are the distributions of sample proportions we expect to see. This is the distribution of people who will come into our restaurant and request, or demand rather, non-smoking. We expect 59%, and then we could see 60% or 63%. Things out here start to seem a little odd. As in, on any given day when 136 people come into the restaurant, we'd probably not expect to see, and I can get that extra decimal on here, I think, or not. We'd probably not see up here at the third standard deviation. Now this is what this question asks for. This question wants to know, we want to be doubly sure that we have enough seating for all these people who demand non-smoking. We expect 59%, but at the top, 1 standard deviation, 2 standard deviation, 3 standard deviations, what percent of the restaurant would we need to be non-smoking? With this in mind, let's go find 3 standard deviations above the mean. I'm simply taking this and timesing it by 3 standard deviations, taking this rather, timesing by 3 to get 3 standard deviations. I'm now going to add that to the mean, and that would be the number right over here, which is not on the screen. This is the third standard deviation. Now this is a percentage, as in this is the percent, or the 3 standard deviations above the mean, of how the proportion of people who will demand non-smoking. This is not likely to occur. This is the top 0.15%. As you notice, it's not going to happen a lot of times if this is the truth. But this is the percentage. So let's remember we had 136 people. So that means this percentage of 136 is what we're interested in. That's 97 people. On the days where people are really demanding it, we'd have 97 people demanding it. So remember, once again, this is actually turning it back into a real number right here. There should be 97 non-smoking seats to ensure that we have the mean plus 3 standard deviations above. This is like the insurance that we have enough non-smoking. Sorry, smokers. Good deal. This is the switch over, but let's put this as the last thing in the video because I think the rest deal with means. This still kind of applies to the other distribution, this distribution of sample proportions, but this is kind of the switch to the distribution of sample means. So let's do this here and then do it as a review in the next one. When we have a distribution, describe the shape, center, and spread. A sample is chosen randomly from a population that can be described as a normal model. Now I want to make this clear. We are doing a sample from a normal model, and if it's normal, then it'll stay normal with a center of the mean and a standard deviation of the mean divided by the square root, It'll have a center of the mean and a standard deviation of sigma over the square root of n. This is how we describe it in the formula we will use here. As our sample size increases, this will cause the standard deviations to become smaller. A lot of times we might call it a standard error of the mean, but the center will remain the same.
I wear my sunglasses at night so I can't bang my head